lectures so we can listen to them again later?
Yes.
Okay.
Want to do audio or video?
Just on my phone.
Okay.
Okay.
I'll also post lecture.
Okay.
But we can.
Okay. Or you can
like this the whole time. That's kind of uncomfortable. I can do that for like 5 minutes. I got like a good solid 5 in me, and then I gotta take an 8. Sure. Look at you. You got a little case too. Dude, I'm not gonna lie. When I saw yours last semester, I was like, I know she did not go out and buy this special container for her gum.
Oh, really?
Dude, I know it's really late now. Dude, I've been so loud from my parents my entire life, and it's been 25 years, so. They will never adjust to me and my decibels. I will always be too abrasive. Hello, Dr. Chapter. How are you?
I'm good. How are you?
Great.
I like your friend's haircut. Hairstyle.
Oh,
How did you bleach it again this week? Oh, it's white on the top.
Oh, that's because I found the pool and I first went around it for rain.
Did anybody go to international festival? Something
No.
is going on in Citrus.
Oh, the downtown festival?
Yeah.
I was supposed,
Festival was at the down.
my cousin went, I think.
I didn't, but I heard it was good.
My cousin Anthony is all about different cultures. I felt really weird that I'm in this shirt and then I wasn't coming in snacks.
I wouldn't even need my computer. I just want to leave it open so I have something good to look at every once in a while. I just need a break from my eyes. That's where I wish I was.
Okay, everybody, so we were talking about the blood, and the last thing we were talking was the blood clot or hemostasis, stoppage or arrest of bleeding. So you must remember there are 3 steps in hemostasis. What are those? Muscular spasm that I explained to you. I'm just quickly going over again. This is the blood vessel. If you get a cut here, what will happen? The size of the lumen will get narrow. So that is the constriction. Muscular spasm will occur. So this side of the lumen will get narrow. So that will reduce the blood loss. The lumen will get narrow. Then platelet loves rough surface. So what will happen? The platelet will start to get attached. There. And many platelets together will form a plug that is called platelet plug. So first thing is constriction, muscular spasm, and then platelet plug formation. And then what will happen is semi-solid jelly-like structure will be formed here, and that is the clot. Okay, so clot formation. So three things. Vascular spasm, look at me. This is the lumen of the blood vessel. When it gets cut, it will get narrow. Okay? Then platelets will aggregate there, and then a semi-solid structure will be formed, that is called the clot. Three things will happen to stop bleeding. Now, how a clot is formed, we'll talk about it. Okay? So, two pathways of clot formation. One is called extrinsic pathway. Extrinsic pathway, and another pathway is called intrinsic. Okay?
Are you not taking it up yet?
You need it?
I think I would like it.
Okay. I thought I did. I thought you were looking at it. Okay. Good. So, here you see those three steps we talked about before. Vascular spasm, platelet plaque formation, and coagulation. So two pathways, extrinsic and intrinsic. Okay. And several reactions take place in both pathways. So a number of reactions take place in both extrinsic and intrinsic pathways. Okay. So in a left side you see intrinsic pathway, and right side you see extrinsic pathway. Okay. And the numbers, you see the Roman numbers, right? Those are the coagulation factors. There are 13 coagulation factors in our blood, and they are named like this: coagulation factor number 1, number 2, number 3, number 4, 5, okay, then up to 30. So that's why you see those numbers. Those are called the coagulation factors. We indicate by Roman numbers. Anyway, got it? So you see the number of reactions take place in both intrinsic and extrinsic pathways. You don't have to remember all those reactions. What you need to know is, finally, you see, a common product you will get in both extrinsic and intrinsic pathway. Same product will be the outcome. What is that? That product is called prothrombin activator. Prothrombin activator. So both intrinsic and extrinsic pathways, whichever you go, will produce prothrombin activator ion. And its name is telling you its function. Prothrombin activator, right? That means what? It will activate prothrombin. So its function is acting on prothrombin, which is also a blood clot factor or coagulation factor, to thrombin. Okay, so prothrombin activator works on prothrombin. Its name is prothrombin activator, so it will work on prothrombin method to activate it. And this is the active form. This is inactive form. Inactive prothrombin to active thrombin. So prothrombin activator will do that. Is it clear? Convert inactive prothrombin to active what? Thrombin. Okay. And this active thrombin will work on fibrinogen. Fibrinogen you must remember one type of plasma protein. 2, fibrin. So prothrombin activator will convert prothrombin to thrombin, and then active thrombin will convert fibrinogen to fibrin. So you see, when we talked about the plasma proteins, 3 types of plasma proteins I mentioned: albumins, globulins, fibrinogen. So this is one type of plasma protein. Okay, and then what will happen? You see, the fibrins are threads like this. Fibrin threads. Fibrin are what? Threads. Like this. What will happen next? The fibrin threads will get attached to each other like this in different directions and will form a mesh that is called fibrin mesh. It's a kind of network. So, make sense? Got it? So fibrin mesh. That fibrin mesh will do what? Will cover the platelet plug that is formed here. So basically fibrin mesh is the clot, and it will then cover the platelet plug and make it very stable. It will not get detached. So that mesh will stabilize it. Stabilize the clot or platelet plug. So that is the coagulation. Okay. Now let's go to next slide. You see here both extrinsic and intrinsic pathways are producing finally what? Look at the bottom. Prothrombin activator, right? Through a number of reactions. And then you see prothrombin activator converts prothrombin to thrombin, right? Then active thrombin will work on fibrinogen and converts it to fibrin. And fibrin threads will get attached to each other and form a mesh that is called fibrin mesh. Is it clear? Now, one thing you need to remember, that calcium plays a very important role. You see, in many of these reactions, you see calcium, Ca++. So calcium ion, not only calcium in ionic form plays a very important role in blood clot formation, because many reactions are helped by calcium. That's why lack of calcium in blood will prevent or will not let blood clot formation. If I remove calcium from the blood, that blood will not get clot. Make sense? Because we will not go through these reactions. So I can stop these reactions by removing calcium from the blood. And then what we do to keep the blood liquid. After I collect your blood, okay, if I want to keep it liquid, I can remove calcium from there. Okay? So we will not go through these reactions. So there are some chemicals called calcium chelating agents that will chelate, take the calcium out. Make sense? So it will stay liquid. Sometimes, for lab tests, we want to keep the blood liquid, right, for a long time. If it gets clot, you won't be able to do that. Sometimes we use heparin, that is anticoagulant. Both will work same. Okay. So this is a picture of fibrin mesh, you see, and some red blood cells are trapped into it. Clot retraction. After the clot is formed, so now this is the clot, what will happen? The clot will get squeezed smaller, and that is called clot retraction. inside these platelets, you all should remember from NP1. Do you remember actin myosin? Right? Actin myosin. Remember that?
Yeah.
They helps in contraction of muscle, right? So inside these platelets, you also have actin myosin. So what happens? The platelets get contracted because of the actin myosin, okay? Contractile proteins. So when all these platelets in the plug will contract, the whole structure will get smaller, right? Squeeze. And that happens within 30 to 60 minutes after clot is formed. After clot is formed, within 30 to 60 minutes, retraction occurs. And when it squeezes, what happens? The fluid, it is a semi-solid, so there is some fluid inside, will come out. Okay, the fluid will come out from the clot. That fluid is called serum. Fluid is called serum. In this fluid that comes out from the clot, you have everything same as plasma, liquid part of the blood, except the clot factors, because clot factors have been used up to form the clot. So serum, we say, is plasma minus clot factors. Because this fluid doesn't have clot factors, the clot factors have been used to form the clot. Okay? Now, what is the difference between extrinsic and intrinsic pathways? When you get a cut, okay? When you get a cut, tissue injury occurs, right? Tissue injury occurs. So, some chemicals are released from the tissue, okay? That triggers extrinsic factor. So remember, tissue release some chemicals. That triggers what? Extrinsic factor. This one. So I can say that tissue factors, tissue injury releases tissue factors, and they trigger the extrinsic or initiate the extrinsic pathway. Now, if no tissue injury occurs, like, if I take your blood out very nicely, gently, without damaging the tissue, okay, and put in a test tube, blood clot will be formed, right? But no tissue factor is there, makes sense? But still blood clot will be formed. So in that case, that is what? Intrinsic pathway, okay? That means inside the blood you have something that is initiating that. That is called plasma factors. Inside the plasma, you have some chemicals that will initiate that. No tissue injury, no tissue factor, but still blood clot will be formed. That is intrinsic pathway. Now you tell me, it's a common sense question. Sometimes you know that inside the blood vessel, blood clot is formed, right? That is dangerous, right? Blood clot is formed inside the blood vessel without any injury. So that is what? Intrinsic pathway or extrinsic? Intrinsic, right? Intrinsic. So intrinsic pathway can form clot inside the blood vessel without any injury of the tissue, right? So that would be an example of intrinsic. But usually we get cut, then blood clot is formed, that is tissue damage occurs, right? So blood vessel rupture occurs, tissue factors are released, so that triggers the extrinsic pattern. Right. Disorders of homeostasis. Blood clot formation is a natural process to stop your bleeding, which is very good. Okay? But when we say disorder, that term disorder, right? That means abnormal. That is not normal. So when you get a cut, blood clot is formed. That is normal or abnormal? Normal, right? When you get a cut, blood clot is formed. That is normal. That is expected, right? Desired. But if a blood clot is formed inside the blood vessel, that is abnormal, right? That is not desirable. That is not expected, right? So that is a clinical condition, disorder. Okay. Now, two types of disorder can occur. One is clot formation. Okay. This is the blood vessel, and in the wall of the blood vessel, we got a clot. Okay. This is attached to the wall of the blood vessel. Okay. So this is called a thrombus. Thrombus attached to the wall. Sometimes what happens, this clot may get detached. It may get detached and start to move with the blood, right? Inside the blood vessel, makes sense? Will move. And for example, a clot has been formed in the lung. Now it got detached, right? And started to move. That is called an embolus. So this is an embolus. Okay. So free floating clot is embolus, and fixed attached to the wall is a thrombus. Make sense? Right. Now embolus could be very dangerous because sometimes you see that clot is formed in the lung or in the leg. Okay, and then move and go to the brain and heart. Okay, can block the coronary artery, can block the artery in the brain, and that could be dangerous, right? So, embolus could be very dangerous. But both are related to clot, right? One is free, another is attached. So, those are two conditions. Those are thromboembolic disorder, undesirable clot formation. Thromboembolic disorder. Now another disorder can occur, it's like opposite of clot. If clot formation doesn't occur, you got a cut here, the bleeding will continue, right? If clot is not formed, but delayed, a long time bleeding will occur, right? So that is bleeding disorder. That also happens due to lack of what? Clotting factors. You remember I said 30 clotting factors, right? Or clot factors. If lack of any of those factors in your blood, then what will happen? Clot will be formed, but it will take longer time. Is it clear? So, the clot formation will be delayed. More prolonged bleeding will occur. So it could be, both are bad. Too much clot formation is bad, or not clot formation is bad. How clot formation could be prevented? Undesirable clot formation could be prevented. There are some chemicals. Aspirin. Doctors often suggest the older people to take aspirin, right? To prevent the clot. Why? Because when we get old, you see this is the blood vessel. When we get old, inflammation occurs in the tissue more inflammation occurs, right? So inside the blood vessel, the surface gets rough due to inflammation. Surface gets what? Rough. Normally inside the blood vessel, the surface should be very smooth, right? But if it gets rough, I told you platelets love what? Rough surface. Remember that? Platelets love rough surface. So what happens? Sometimes the platelets love this surface and will get attached, and will tell other platelets to come and get it, right? So the chance of getting clot in older people is more. Make sense? And platelets, what the platelets do, release a chemical, two chemicals actually. These are the platelets. When they get attached to the rough surface, they start to release those chemicals. One is called ADP, another is called thromboxane A2. Thromboxane A2 and ADP. So platelets release those two chemicals when they get attached to the rough surface. And these two chemicals make the platelet surface sticky. So more and more platelet will get attached there. Understand? So when the surface gets sticky, more and more platelet can easily get attached to it. Okay? And that's how it is aggravated. So aspirin now does what? Prevents this. So the surface will not get sticky. Okay? Will not get attached to the wall. Aspirin also prevents inflammation. So in different ways, aspirin is helpful to prevent platelet plaque formation. Heparin is a natural anticoagulant. You know, basophil, one type of white blood cells release heparin. We have talked about this in last class. So heparin in your blood must be present all the time to keep the blood liquid. It's natural anticoagulant. Warfarin is an artificial anticoagulant. So those are the commonly used chemicals that are that prevent undesirable clot formation. Okay, so you got some idea about the clot or coagulation, hemostasis of bleeding stops. Now we will see the blood typing or blood grouping. There are different types of blood, right? Or different groups of blood. Why different people have different blood type? The reason is, who determines the blood type? Very simple. Blood type is determined by the antigens present on the surface of the red blood cells. So let me draw a red blood cell. This is a red blood cell, okay? And on the surface of the red blood cell, what kind of antigens are present, that determines the blood type. So this is a red blood cell, and these are the antigens. This red blood cell has antigen A. So antigen A. So these are antigen A. So this person's blood type is type A. This is another person's red blood cell, and on the surface of red blood cell, this person has a different type of antigen, that is antigen B. Antigen what? B. So this person's blood type is what? B. This person's blood type is A. Makes sense? What kind of antigen is present, that determines the blood type. Very simple. Okay. If someone has both A and B, then what will be the blood type? AB. So this person has this as well as this. So blood type is what? AB. Makes sense? If the person doesn't have A or B, neither A nor B, what will be the type? O. So no antigen. No antigen on the surface of the red blood cell. Make sense? So that is how blood type is determined by A, presence or absence of A or B antigens on the surface of the red blood cells. Make sense? Now, there are some other antigens which do not participate in blood typing, small, very weak. antigens. There are more than 30 different types of antigens present on the surface of red blood cell. Some of those weaks are MNS, Duffy, Cal, Lewis, those are the names, but those do not participate in blood type determination. Only these are the factors. Now, there is another type of antigen which is important, that is called D antigen. So this is D. D antigen. If this one is present, blood type is positive. So this is A positive. Make sense? If D is present, then it is what? Positive. If D is absent, it is negative. Okay? So this is D. So what will be the blood type? This one? AB positive. Make sense? This one doesn't have D. So what is the blood type? B negative. Make sense? So this is B negative. This is AB positive because D is there. D is here. So A positive. Make sense? So three antigens are really important, A, B, and D, to give you the blood type. Okay. Now, outside of the blood cells, in your blood, you have the liquid. What is the name of that liquid? Plasma. You all know that, right? So, you have plasma here. Okay. In the plasma, you have antibody. Antibody. So on the surface of red blood cell, you have antigens that determine the blood type, right? But in the plasma, you have what? Antibody. There is a rule. That rule is very important. Rule is, if any antigen is present on the surface of red blood cell, same or corresponding antibody must be what? Absent. Remember. So what is the, let's remove this one for a while. So what type of antigens are here on the surface? A, right? So A antibody must be what? Absent. So which antibody will be present? The other one, B. A will be, first thing, A will be what? Absent. Is it clear? So who should be present? B. Now why A must be absent? You see here, if A is present there, then what will happen? Strong reaction will occur between antigen and antibody same time, right? So very strong reaction will occur that will called agglutination, will clamp and break the red blood cells. Same type of antibody will attach to the antigens. Make sense? So we'll do what? We'll rupture the red blood cells. So what is safe? Same type or opposite type? Opposite. So B antibody will be present. Is it clear? So this is the rule. Now you tell me, this is the plasma around this person's red blood cell. So which antigens are present? B. So who should be present here? If B is present here, that will be dangerous, right? So corresponding antibody must be absent. That is the rule. The opposite one should be present. Now let's say this one. This blood type is AB. So on the surface you have what? Both A and B, right? So no antibody, neither A nor B. Make sense? In the plasma. Now let's say this one. Now you tell me, what kind of antibody should be or should not be? Then we both should be here, right? Because on the surface neither A nor B. So both can be present. It is safe. Because on the surface there is no A, no B, right? So it is safe. So you have to think that which is safe, which is not safe. Okay? So this is how the antigen and antibody are present. Now, let's think another way. This is the donor, blood donor, and this is the recipient. Okay, recipient. So this blood type is B, this one. Okay, B type blood, because B antigens, right, on the surface. Is it clear? In the plasma, this person has what? A antibody, right? Okay. Now, if this person wants to give blood to this person, this is recipient, right? So B wants to give blood to A. Okay? So this blood enters into this person's body. Okay? What will happen? In the plasma, this blood has what? This is A, right? So in the plasma, it has B, right? Opposite. Now you see, on the surface of this blood, you have what? B, right? And in the plasma of the recipient, you have huge amount of B, because plasma is everywhere, right? So what will happen? Immediately, this B will destroy the cell membrane, because B, same type. Make sense? Cell membranes will be destroyed. Hemolysis will occur, right? So that is dangerous. So this person cannot give blood to this person. Make sense? Now, from this, one more message you get that is also very important when we do the blood transfusion. We always look at the antigen of the donor and antibody of the recipient. Those two factors. Antigens on the red blood cell surface of the donor and antibody of the recipient. Make sense? We'll see these two. So this is not compatible. Okay. Now let's see this one. If I want to give this one to this person, B antigen, A antibody, right? Here. So same. Makes sense? Same type of blood you can always give, because B antigen here, A antibody, no reaction. Now, this one, let's see this one. How do you think?
I thought they could get both.
Yes, you can. If you really need in emergency situation, AB is universal recipient. We say recipient, okay? Universal recipient. It can take any. Why? You see here. In the plasma, this one has no antibody, right? So whatever you give, because we will consider the plasma of the recipient, right? Remember? So forget everything. In the plasma of the recipient, you have no antibody.
Oh, yeah.
So whatever you give, it is safe, because no antibody is there, no reaction will occur. Make sense? So universal recipient. There could be small reactions because there are 30 more than 30 other antigens, right? Those are weak, but it is still not dangerous.
It had to be the same, like if it's positive or negative, like.
Yeah, positive, negative will also cause some transfusion reactions. Yeah, will cause some because of D. You know, so always it's good, recommended that positive will give to positive, negative will give to negative, because D is not as strong as AB, but that can also cause transfusion reactions. Okay? In a situation where, like in a battlefield, in that case, you can universal recipient can take any. Okay, will give any to universal recipient, or O will give to anybody, because O is called universal donor. Make sense? So it can be given, but normal condition we will avoid that because there are other factors. Okay, so now let's see B we want to give to O. What? No, that is dangerous because O will not take any except O because it has both antibodies, right? If you give A, you have A antibody. If you give B, you have B antibody. Make sense? So O will not accept. So that's why O will not take, but it can be given to any. Let's think opposite way now. O. Why O can be given to everybody? Let's see. Because there is no antigen on the surface. Whatever the antibody is, doesn't matter if you don't have antigen on the surface, right? So antibody will not be able to destroy the membrane. So O can be given to anybody. So a couple of things you need to remember. One is who determines the blood type? Antigens on the red blood cells, right? Presence or absence. And what is a rule for antibody in the plasma?
Must be absent.
Same type of antibody, corresponding antibody must be what?
Absent.
Absent in the plasma, right? That means what? Other type will be present. Okay? So that is another. And another rule, very important, when we do transfusion, we look at the antigen of the donor, okay, and antibody of the recipient. Make sense? That means what? Red blood cell of the donor and plasma of the recipient. We look at those two. Now you can ask me, what's wrong if let's say this person has A antibody, right? This is donor, has A antibody, right? And this recipient has on the red blood cell surface A antigen, right? Now you can tell me, you can ask me why these red blood cells will not be destroyed. Because, hold on, this is B, okay, yeah. So if I give this to this one has B antibody. Am I right? B antibody, right? This one has what? This is A. So now, this is A. No, this is B type, right?
Yeah, so
This is B.
So it has A antigens, right? Or antibodies.
This one has A antibody. Yeah. B antigen.
Yeah.
A antibody. Is it clear? This is blood type B, right? So B antigen, A antibody. Okay. This is a different type of blood. A blood type, right? Blood type A. So it has A antigen, B antibody. Now let's go back. First condition, when I said B will be given to A person, then what will happen? This antibody will destroy because on the surface you have B. Make sense? Now, why these antibodies? Why we are not talking about this cell? Because it has A antigen. This is A antibody, right? This can also destroy this. Why we are not talking about that? Why we are talking only the antigens of the donor, recipient, donor. The reason is, when I give you a bag of blood, okay? When I give you a bag of blood, your plasma, donor's plasma, will get diluted in huge amount of recipient's blood, okay? So, this plasma will get diluted when it will enter into this. So that plasma or antibody is no more strong. Like if you dilute something, right, in huge amount of blood, then the effective or strength or effectiveness will be decreased. That's why I said we will consider only two things. What?
Red blood cells of donor
And plasma of
recipient.
the recipient. Not opposite. We are not thinking about recipient's red blood cell and plasma of the donor, because plasma of the donor will be diluted, will get diluted, and the strength will go down a lot. So that is not strong enough to destroy the recipient's blood cell. So this is not strong enough to destroy this cell. This is not strong enough to destroy this cell. But this is strong enough to destroy this cell. Make sense? Because in recipient you have this a lot. When this will get into, this will get diluted. Okay. So just know that we consider the donor's red blood cell and recipient's plasma, not opposite. We don't consider recipient's red blood cell, donor's plasma. Okay, now erythroblastosis fetalis. Erythroblastosis fetalis is a clinical condition, and its name, if you just think,